Yes, good evening, ladies and gentlemen. Yes, it's Xavier Janvier we are talking with again. So I embrace you again in my YouTube channel, of course. Yeah, today is our topic is gonna be based or is gonna be centered about the kinetic energy and the potential energy. Also, because the total of people just confused about kinetic energy and the potential energy is like going to be similar, but it's not similar, and it becomes sometimes difficult for people to distinguish. But it's not the same, by the way. Yeah, it's not the same, by the way. So that's why I have just get rid of some little things not to understand what is a kinetic energy, of course, because it's a really, really interesting the basics topics when you are going to read about physics, of course. Yeah, we are going to see what is a kinetic energy. People do not understand what is a kinetic energy, of course. So a kinetic energy is an energy possessed by an object due to its motion. So when I say motion, it means move. It means move. If an object is moving, it means that it have a kinetic energy. So the kinetic energy is going to depend on the mass of the object, of course, and the speed of that object when the object is moving. That is the tricky exam questions that you can just understand very well when you are thinking about this kinetic energy and the potential energy, by the way. So simply means that when an object is moving, so it has a kinetic energy because it is moving. That means that in contrary, if an object doesn't move, it means that it doesn't have a kinetic energy because it means that the object is disposed on the ground. It doesn't have a kinetic energy. So an energy is going to depend on the mass of the object and the speed of that object is moving. So in order to understand so I want to give you some examples. So, for instance, when I have a bar, yeah, a bar is like a typical example that everyone can understand well. These things about kinetic energy. So, this ball have been shooted, and it is throwing to the speed of 5 meter per seconds. So this ball have this speed 5 meter per seconds. So it means that this ball, because it's moving, it has a kinetic energy because it is moving. So another tip example, for instance, if you have a block, let's say a block. So this block it just disposed on the ground. It just disposed on the ground. It means that this box is not moving, is not pulling. It is like disposed on the ground. It doesn't move. No one is shaking. No one is just maybe tripotated that block. It's just disposed on the ground. It means that it doesn't have no kinetic energy because it is not moving. So I think everyone get a little things about this kinetic energy. So in simple ways, kinetic energy is occur when an object is moving, when an object have a motion. That means that if object doesn't have a motion, it means it doesn't have a kinetic energy. So the standard formula about kinetic energy, when I write QE, it means kinetic energy is 1/2 v squared. That's the standard formula about kinetic energy, and this m means mass, which is kilogram, and this v is speed, which is measured in meter per seconds. And kinetic energy, by the way, is like joule. It's measured in joule. When you are calculating the kinetic energy, you just put the joule. It's measured in joule, of course. So some tricky exams question that used to come. Suppose you are calculating the kinetic energy, then they say and they ask you if you double the mass of an object, how the kinetic energy is going to be changed. So that is a tricky question, of course, that you may need to understand well. So we need to puzzle for everything so that maybe you can understand deeply how this kinetic energy going to be changed every time. So they say Or if you double the mass of an object, how the kinetic energy is going to be changed, as well as the formula says, kinetic energy is going to be 1 over v square. So they say this m is doubled. This m is doubled. So what happened for the kinetic energy? So let's do like this. So I'm doubling the mass of an object. Let's say 1 over 2 mv square. So I'm going to take this mass. So this is going to be ignored. This constant is going to be ignored. So let's say 2 and v square occurs. So I'm going to get 2. So it means that the kinetic energy is going to be 2. So it means that if you double the mass of an object, if it has a motion, so the kinetic energy is going to be doubled. The kinetic energy is going to be doubled. So another trick exam question: what if you double the speed? What if you double the speed? Let's see if you double the speed. So 1 over 2 mv square. So here I'm going to take 1 as a mass, and I'm going to double the speed. So here is going to be 4. So if you double the speed in motion, when you're dealing about the kinetic energy, is going to be quadruple. So here the kinetic energy is going to be quadrupled. Yes, it's going to be quite a bit about the kinetic energy. You need to understand these two concepts, of course, because that is very, very interesting. So the kinetic energy is going to be doubled when you double the mass of an object, and the kinetic energy is going to be quadrupled when you double the speed, of course. So another things that we could know about kinetic energy. So let's think about we increase mass. The mass of object is increased by times 3, and we increase also the speed of an object by times 4. What happened for the kinetic energy? So as well, kinetic energy is 1 over 2 mv squared. This is a standard formula as well. So I'm going to ignore this constant. I'm not thinking about this constant, but also to use when you are calculating, when you are finding the answers. So it means I'm going to triple the mass and quadruple the speed. So it means the 3 times 16 is going to be 48. So the kinetic energy is going to be 48 joule. So what happened here? So when the kinetic energy is equal to 48, it increased by a factor. So it means that when you triple the speed, or double or quadruple the speed, the kinetic energy is going to be increased by the factor of what you are using. So that is how the kinetic energy works. So we're gonna have some exercise in order to understand more about these topics about kinetic energy. Let's say problem. Let's say a ball. Of a mass of 2 kilogram is moving at 3 meter per second. Let's say along the side. So the question is calculate the kinetic energy. So the question says a ball of a mass of 2 kilogram is moving at 3 meter per second along the side. This means that the ball is shooted along the side, maybe the direction north, left side, everything like this. So they ask you to calculate about kinetic energy of this ball. So it's a really question, but you can even just solve it in your mind, because it doesn't need more calculation or deeper calculation. So it's like kinetic energy here is going to be 1 over 2, the standard formula as well. So it's going to be 1 over 2, or what is the mass and what is the speed. So here we need to understand which one is given, the given here, and required. So here mass is 2 kilogram and speed is 3 meter per second. What is required? The required is a kinetic energy. Kinetic energy is required. So the formula says that the kinetic energy is 1 over 2 mv square. So it means that m is 2 kilograms and v is 3, speed is 3 meter per second, so square. So here I'm going to get 1 over 2 times 2, 9. So it's 2 over 2 times 9, which is equal to 9 joules. So this ball is shooting through the 9 joule of kinetic energy. So I think everyone get a little bit about the kinetic energy. So next lesson we are going to focus on potential energy, which is a very, very interesting topic, of course, because those kinetic and potential energy are used to be similar and is sometimes used to be cohesive score, of course. So thank you very much for your attending. So I hope we're going to improve my knowledge about this physics we are starting. So have a good welfare, guys.